The diameter of the sun's path is constantly changing, diminishing from December 21st to June 15th, and enlarging from June to December. This is a matter of absolute certainty, proved by what is called in technical language the northern and southern declination, which is simply saying that the sun's path is nearest to the pole in summer and furthest away from it in winter. This difference in position gives to rise the difference of altitude as observed at various periods of the year, and which is shewn in the following table given in the Illustrated London Almanac for year 1848 by Mr. Glaisher of the Royal Observatory, Greenwich. Quote, sun's altitude at the time of southing or being on the meridian. Section 5, Table 1. Section 6, cause of day and night, seasons, etc. Still looking at figure 27, the sun S describes the circle AAA on the 21st December once in 24 hours. Hence, in that period, day and night occur to every part of the earth, except within the Arctic Circle. The light of the sun gradually diminishing from S to the Arctic Circle 1, 2, 3, where it becomes twilight, does so accordingly to the well-known law of radiation, equally in all directions. Hence, the circle 4, 5, 6 represents the whole extent of the sun's light at any given time. The arc 4E is the advancing or morning twilight, and 6E the receding or evening twilight. To every place underneath a line drawn across the circle through S to N is noonday. It will now be easily understood that as the sun S moves in the direction of the arrows or from right to left, and completes the circle AAA in 24 hours, it will produce in that period morning, noon, evening, and night to all parts of the earth in succession. On referring to the diagram, it will be seen that to England E, the length of the day at this time of the year is the shortest, the amount of light being produced by the arc EEE, and also that the northern center N remains in darkness. During the whole day revolutions of the sun, the light of which terminates at the Arctic Circle 1, 2, 3, thus morning, noon, evening, midnight, the shortest days, or the winter season, and the constant or 6 months darkness at the pole are all part of one general phenomenon. As the sun's path begins now to diminish every day until 6 months, or on the 15th of June, it describes the circles BBB. It is evident that the same extent of sunlight will reach over or beyond the North Pole, as shown in the following diagram, figure 28, when morning, noon, evening, and night will again occur as before, section 6, figure 1. But the amount of light passing over England, represented by the arc EEE, is now much larger than when the sun upon the circle AAA, and represents the longest days or the summer season and the constant or 6 months light at the pole. Thus, day and night, long and short days, winter and summer, the long periods of alternate light and darkness at the pole arise simply from the sun's position in relation to the North Pole. If the earth is a globe, it is evident that winter and summer and long and short days will be of the same character and duration in corresponding latitudes, in the southern as in the northern hemisphere. But we find that in many respects there is a marked difference. For instance, New Zealand, where the latitude is about the same as in England, a remarkable difference exists in the length of day and night. In the Cook's Strait Almanac for 1848, it is stated at Wellington, this is a quote, New Zealand, December 21st, sun rises 4 hours 31 minutes and sets at 7 hours 29 minutes, the day being 14 hours 58 minutes. June 21st, sun rises at 7 hours 29 minutes and sets at 4 hours 31 minutes, the day being 9 hours and 2 minutes. In England, the longest day is the 16th, 16 hours 34 minutes, and the shortest day is 7 hours, 45 minutes. Thus, the longest day in New Zealand is 1 hour and 36 minutes shorter than the longest day in England, and the shortest day in New Zealand is 1 hour and 17 minutes longer than the shortest day in England. In a recently published pamphlet by W. Swanson, Esquire, Attorney General, the following passage occurs. Quote, "Compared with an English summer, that of Auckland is but a little warmer, though much longer, but the nights in New Zealand are always cool and refreshing. These days are 1 hour shorter in the summer and 1 hour longer in the winter than in England, or of twilight there is little or none." End quote. From a work also recently published on New Zealand by Arthur S. Thompson, M.D., the following sentences are quoted. Quote, "The summer mornings, even in the warmest parts of the colony, are sufficiently fresh to exhilarate without chilling, and the seasons glide imperceptibly into each other. The days are an hour shorter at each end of the day in summer, and an hour longer in the winter than in England." A letter from a correspondent in New Zealand, dated on Nelson, September 15, 1857, contains the subjoined passages. Quote, "Even in summer, people here have no notion of going without fires in the evening. But then, though the days are very warm and sunny, the nights are always cold. For 7 months last summer we had not one day that the sun did not shine as brilliantly as it does in England in the finest day of June. And though it has more power here, the heat is not nearly so oppressive. But then there is not the twilight which you get in England. Here it is light till about 8 o'clock, then in a few minutes it becomes too dark to see anything, and the change comes over in almost no time." End quote. Quote, "Twilight lasts but a short time and so low at altitude as 28 degrees, and no sooner does the sun peep above the horizon that all the gorgeous parade by which he is preceded is shaken off, and he comes in upon in the most abrupt and unceremonious way imaginable." End quote. These various peculiarities could not exist in the southern region if the earth were spherical and moved upon axis and in an orbit around the sun. If the sun is fixed and the earth revolves underneath it, the same phenomenon should exist at the same distance on each side of the equator. But such is not the case. What can operate to cause the twilight in New Zealand to be so much more sudden than it is in England? The southern, quote, hemisphere cannot revolve more rapidly than the northern. The distance round a globe would be the same at 50 degrees south as 50 degrees north, and as the whole globe would revolve once in 24 hours, the surface of the two places would move underneath the sun, which with the same velocity, and the light would approach in these quotes are from Captain Basil Hall, and the light would approach in the morning and recede in the evening in exactly the same manner. And yet the very contrary is the fact. The twilight in England in summer is slow and gradual, but in New Zealand it is rapid and abrupt, a difference which is altogether incompatible with the doctrine of the earth's rotundity. But the earth a plane, and it is a simple, quote, matter of course, end quote. Let E in figure 28 represent England and W New Zealand. The radius NE and the consequent circle round N is much less than the radius NW and its consequent circle round the same point. But as the larger circle, radius NW, is passed over by the sunlight in the same 24 hours as the smaller circle, radius NE, the velocity is proportionately greater. The velocity is the space passed over multiplied by the time in passing, and as the space over New Zealand is much greater than the space over England, the velocity of the sunlight must be much greater, and its morning and evening twilight necessarily more, quote, abrupt and unceremonious, end quote. And, therefore, it might be said, with strictly logical accuracy, the earth is a plane and cannot possibly be a globe. End section 6. Section 7. Cause of, quote, sunrise and sunset, end quote. Although the sun is at all times above and parallel to the earth's surface, he appears to ascend the firmament from morning till noon, and to descend and sink below the horizon at the evening. This arises from a simple and everywhere visible law of perspective. A flock of birds, when passing over a flat or marshy country, always appears to descend as it recedes, and if the flock is extensive, the first bird appears lower or nearer to the horizon than the last. When a balloon sails from an observer without increasing or decreasing its altitude, it appears gradually to approach the horizon. The farthest light in a row of lamps appears the lowest, although each one has the same altitude. Bearing these phenomena in mind, it will easily be seen how the sun, although always parallel to the surface of the earth, must appear to ascend when approaching and descend after leaving the meridian or noonday position. Let the line AB in figure 29, this is section 7, figure 1, figure 29, section 7, figure 1, represents a portion of the Earth's surface, CD of the sun's path, and HH, the line of sight. The surface of the Earth, AB, will appear to ascend from B to H, forming the horizon. When the sun is traversing the line CD in the direction of the arrows, he will appear to emerge from the horizon, H, and to gradually ascend the line HD. When the position 1, he will appear to be at the point 2, and when at 3, the apparent position will be at 4. But when he arrives upon the meridian, D, his apparent and actual or noonday position will be the same. But now from the point D, the sun will appear to descend, as in figure 30, and when he has passed from D to 1, he will appear at 2, and when really at 3 will appear at 4. Section 7, figure 2, figure 30, and when he has passed from D to 1, he will appear at 2, and when really at 3 will appear at 4, and thus, continuing his course in the direction DC, he will reach the horizon at H and disappear, or, quote, set, end quote, to the observer at HA. Thus, quote, sunrise and sunset, end quote, are phenomena dependent entirely upon the fact that the horizontal lines parallel to each other appear to approach or converge in the distance, and the surface of the earth being horizontal, and the line of sight of the observer and the sun's path being parallel with it, necessarily produce the observed phenomena. End of section 7. Section 8. Cause of sun appearing larger when rising and setting than when on the meridian. It is well known that when a light of any kind shines through the dense medium, it will appear larger than when seen through a lighter medium. This will be more remarkable when the medium holds aqueous particles in solution, as in a damp or foggy atmosphere. The light of a gas lamp will seem greater at given distance than it will under ordinary circumstances. In the diagram, figure 30, it is evident that HD is less than H1, H3, or H5. The latter, H5, represents the greater amount of atmosphere which the sun has to shine through when approaching the horizon. And as the air near the earth is both more dense and more damp, or holds more watery particles in solution, the light of the sun must be dilated or enlarged, as well as modified in color. But the enlarged appearance of the sun when rising and setting is only an optical impression, as proved by actual measurement. If the angle in the sun or moon must be taken either with a tube or micrometer when they appear so large to the eye in the horizon, the measure is identical when they are in the meridian and appear to the eye and mind but half the size. The apparent distance of the horizon is 3 or 4 times greater than the zenith. Hence, the mental mistake of horizontal size for the angular dimensions are equal. The first 5 degrees is apparently to the eye equal to 10 degrees or 15 degrees at 50 degrees or 60 degrees of elevation, and the first 15 degrees fill a space to the eye equal to a third of the quadrant. This is evidently owing to the, quote, habit of sight, end quote, for with an accurate instrument of the measure of 5 degrees near the horizon is equal to 5 degrees in the zenith. End quote. Royal Observatory, Greenwich. Quote, sun's altitude at the time of southing or being on the meridian. Section 5, Table 1. Section 6, cause of day and night, seasons, etc., saying that the sun's path is nearest to the pole in summer and furthest away from it in winter. This difference in position gives to rise the difference of altitude as observed at various periods of the year, and which is shewn in the following table given in the Illustrated London Almanac for year 1848 by Mr. Glacier of the... Still looking at figure 27, the sun S describes the circle AAA on the 21st December once in 24 hours. Hence, in that period, day and night occur to every part of the earth, except within the Arctic Circle. The light of the sun gradually diminishing from S to the Arctic Circle 1, 2, 3, where it becomes twilight, does so accordingly to the well-known law of radiation, equally in all directions. Hence, the circle 4, 5, 6 represents the whole extent of the sun's light at... The diameter of the sun's path is constantly changing, diminishing from December 21st to June 15th, and enlarging from June to December. This is a matter of absolute certainty, proved by what is called in technical language the northern and southern declination, which is simply